If someone told you that for a little over $83,000 you could walk into a showroom and buy a brand new Tesla electric plane, you'd probably think they were joking. After all, aviation has always carried the reputation of being a luxury reserved for corporations or commercial giants. For decades, the idea that flight could be affordable for the average professional or small business seemed far-fetched. But then again, people said the same thing about electric cars. Back in the early 2000s, when Elon Musk suggested that EVs would not only compete with, but outperform gasoline cars, most of the world laughed. And yet, here we are today, with millions of Teslas and other electric vehicles on the road, reshaping the transportation industry. What once sounded crazy became a mainstream reality. Now that same disruptive formula is being aimed directly at the skies, and if history is any guide, the results could completely change what we think is possible for personal and small scale. Aviation. This isn't simply about swapping out a combustion engine for an electric motor or replacing jet fuel with batteries. What's unfolding here is bigger. It's about setting off a chain reaction, one where affordability, efficiency, infrastructure, industrial production, and intelligent software converge. The Tesla super electric plane, with its shocking starting price of just $83,595, represents a convergence of forces that could append decades of bowing dominance and, for the first time in modern history, democratize access to flight in a way that feels both revolutionary and inevitable. It's not just about flying. It's about reshaping the economics of the sky. Before diving deeper into how this plane could flip aviation on its head, it's worth pausing to reflect on what makes this so significant. The Tesla name has already proven that disruption is possible when the right combination of technology, scale, and vision comes together. Cars that once cost nearly $100,000 have been pushed down toward $35,000 or less. Charging networks that once seemed impossible to build have become globally recognized symbols of convenience. Factories that churned out a handful of prototypes now mass-produce vehicles by the millions. And at the heart of it all has been a relentless focus on software, automation, and safety. If that same DNA is applied to aviation, what was once reserved for a handful of pilots and companies may soon be open to families, schools, and communities. The first piece of this disruption is the price. At $83,595, the Tesla super electric plane doesn't just undercut competitors, it obliterates them. Compared to the most common small aircraft in the piston engine category, a brand new Cessna 172, widely used in flight schools and by private pilots, costs between $400,000 and $600,000. A Piper Archer TX sits in the $400,000 to $520,000 range. And if you look at higher-end models like the Cirrus SR22, prices soar past $1 million. These numbers have kept flying out of reach for the average person and have placed a massive barrier between curiosity and ownership. But Tesla's entry price is only about 1/5 Thor in some cases, 1/10 of those figures. It's the equivalent of Tesla doing two planes what it did to luxury sedans, taking something once reserved for the elite and making it accessible for the many. That pricing doesn't just lower the threshold for individual owners, it makes the plane attractive to flying clubs, flight schools, regional services, and even small businesses that need point-to-point travel without relying on airlines. Still, price alone doesn't determine survival in aviation. The real battleground is the cost per flight hour. For years, private flying has been weighed down not only by the cost of purchasing an aircraft, but by the ongoing expenses of operating it. Gasoline is expensive, maintenance is constant, and complexity often pushes costs into the hundreds of dollars per hour. With electric propulsion, everything changes. Electric motors have far fewer moving parts than combustion engines. They don't require oil changes, spark plug replacements, or the same level of mechanical upkeep. Energy costs plummet when you swap aviation fuel, which can exceed $7 a gallon, for electricity that may cost just a fraction of that per kilowatt-hour. Over the course of hundreds or thousands of hours, the difference becomes enormous. A flight school that currently spends a small fortune on fuel and maintenance suddenly sees a future where training costs drop, where students can afford more flight time, and where the barriers to becoming a pilot shrink dramatically. But those advantages only matter if the charging problem is solved. Anyone familiar with EV adoption knows that the weakest link early on wasn't the carrot, was the lack of places to recharge. In aviation, the stakes are even higher. A plane sitting idle because it can't recharge quickly enough destroys the economic advantage. That's where Tesla's concept of an air supercharger network enters. Imagine an aviation version of the supercharger grid that now blankets highways across the world, scaled for aircraft. Instead of waiting hours for a recharge, pilots can land, plug in, and within a manageable turnaround time, be airborne again. For training schools and small services, that means the plane can be flown multiple times a day without the crippling downtime that would kill the business case. For recreational pilots, it means flexibility to take a trip, recharge at a regional hub, and continue on without worrying about fuel logistics. Tesla has already proven it can build and operate large-scale charging infrastructure. Adapting that expertise for the skies may be one of the biggest advantages it brings into aviation. Of course, infrastructure is one part of the equation. Building the planes at scale is another. And here's where many would argue that Tesla faces its biggest challenge. Aircraft manufacturing has traditionally been a slow, labor-intensive industry. Companies like Boeing and Airbus produce relatively small numbers compared to automotive giants. But Tesla has already demonstrated an ability to take industries that move slowly and inject them with a new kind of production philosophy. The same lessons learned from the Gigafactory's automation, robotics, gigapress technology, supply chain mastery could be applied to aviation. If Tesla can ramp production of aircraft the way it scaled the Model 3 or Model Y, the skies could see a flood of new planes at a pace the industry has never experienced. The question isn't whether Tesla can build a prototype plane, it's whether it can build thousands, or even tens of thousands, at a price point that holds steady. If history is any indication, Musk's companies don't enter industries to play small. They enter to dominate at scale. Still, none of this will matter if people don't feel safe. Aviation has a zero-mistake tolerance in a way few industries do. Here is where Tesla's heritage in software comes into play. The company has spent over a decade refining autonomous driving, safety-critical software systems, and real-time monitoring tools. Translated into aviation, that expertise could result in cockpits that are not only easier to use, but fundamentally safer. Flight assistance software could help new pilots with navigation, weather awareness, and decision-making. Advanced autopilot systems could reduce workload and provide backup in case of emergencies. Real-time diagnostics could keep aircraft in top condition and prevent failures before they happen. Just as Tesla's vehicles are known for over-the-air updates that improve functionality after purchase, so too could its aircraft constantly evolve, receiving new features, enhanced safety protocols, and refined user interfaces long after they leave the factory. For an industry where innovation often moves slowly, that would be nothing short of transformative. As this picture comes together, an affordable purchase price, dramatically lower operating costs, rapid charging infrastructure, scaled manufacturing, and advanced safety software, the question shifts from whether Tesla can compete with Boeing to how quickly it can chip away at Boeing's dominance. Boeing has built its empire on large-scale commercial aircraft. But the foundation of aviation itself rests on the smaller planes that train pilots, connect regional areas, and serve as the gateway into flying. If Tesla becomes the dominant force in that sector, it creates a pipeline of pilots, schools, and small businesses that grow up in a Tesla ecosystem. Over time, the influence could extend upward, forcing even giants like Boeing to respond, or risk being bypassed by a new generation of flyers who see electric as the default, not the alternative. This shift also carries profound implications beyond business. It hints at a future where flying is no longer distant or intimidating, but accessible and approachable. Imagine a world where owning a small plane is as common as owning an SUV, where communities once considered remote are connected by affordable electric aviation, and where learning to fly is within reach of far more people than ever before. The environmental angle is equally important. Replacing fossil fuel-burning aircraft with clean electric planes cuts emissions, reduces noise pollution, and makes aviation more sustainable for generations to come. So, when you hear that a Tesla plane is launching at $83,595, the number itself is only the surface story. Beneath it lies a complete reimagining of aviation economics, infrastructure, safety, and culture. Just as Tesla cars forced the auto industry to rethink its assumptions, this plane forces us to consider whether flying can be as common and accessible as driving. The laughter that once greeted the idea of mass-market electric cars may soon be replaced by the same kind of astonishment that followed Tesla's automotive success.